All right. So the first thing that we need to know before we integrate, we have to run over something called partial fractions, right? So let's run over those rules now. Right, so let's run over those rules. Right, so lastly we did the complex numbers and differentiation, right? So let's take a look at integration. Before we start integration, right, as I said, we need to be able to check for converting them part to partial fractions, right? But before we even do partial fraction, anybody remember what the check that we have to make sure? Check and see if it's improper, right? Check and see if the highest power of the numerator is more than or equal to the highest power of the denominator, right? And then if that happens, then we do right. If that happens, right. So by looking at the highest power of x in the numerator and in the denominator, we can determine if the fraction is proper or improper. If the highest power of x in the numerator is more than or equal to the highest power of x in the denominator, improper, more than or equal to earlier. But if it's less than, then it's proper. And then how you go from improper to proper? What you do? Long divide, right? So you get a mixed fraction, right? And then you deal with the proper part. Right. If you end up with any of these here, if you end up with any of these, I want you to remember what to do, right? Right. So I want you to remember that if it's linear underneath, separate them. If it's a repeated linear, one will be linear, one will be repeated. Right, Shivish? If it's a quadratic underneath, numerator is now ax plus e. Okay? So you need to remember quadratic. If it's a repeated quadratic, it's plenty more work. Right? And to be ax plus b over the quadratic plus cx plus d over the repeated quadratic. Okay? By the way, how do we solve this? What technique was used? Huh? Right, we compare coefficients, right? We expand it out, we remove the denominator. So you multiply both sides by the denominator on the left side, and you'll get an expression, and you compare the right hand side to the left hand side. Okay? You compare both sides. You're okay with that? Right, nice. That's proper, improper. So before we do anything now, here's what we need. Right? I don't have it there. But what are the four wheels? Or what are the techniques that we use to integrate fractions? So if you see a fraction, there are 3 to 4 things that you can do. So number one, normal integration. Number one is normal integration. But if you end up with a power to what? -1. Normal integration will not work. So the second thing you check is ln. Second thing you check is ln. So if normal doesn't work and ln doesn't work, third option is what? Tricks, inverse tricks. The third option is inverse tricks. And your last option is what? Huh? Substitution. then 5 is given. Right? 4 is substitution. Okay? Well, when you bracket, make a substitution and work this out. It's very important because 99% of the time, the question is put in partial fractions, then integrate. Okay? So these 4 steps are important, right? Normal, ln, inverse. That's okay? And that's the order you do it in. Check normal. If normal doesn't work, but if when you bring up the denominator, you get the power -1, that will work. Right? Then try ln. If ln doesn't work, then most likely inverse. Okay? And if inverse doesn't work, then you're left with substitution, whatever in the brackets. Okay? Right? How do we integrate now? How do we integrate? Well, simple parts here. Let me go back out and log out here and zoom out here. Do a little zoom out. Nice little zoom there. Right. So how do we integrate? Add 1 to the power, divide by the new power, include this. How would we integrate here? Add 1 to the power, divide by the new power, plus c. Integral of a constant, add the x, plus c. Basic stuff, right? How do we integrate this color here? What's the steps again? Watch this one. Add 1 to the power, divide by the new power, and divide by the differential inside the brackets. That's okay, Emily? 3 steps, right? Add 1 to the power, divide by the new power, and divide by the differential inside the bracket. Then plus c. Methods of integration. So I gave you the 3 types here. Method of integration. Once n is not equal to, that should be minus 1. When n is not equal to minus 1. Okay? So every now and again, I'll put little mistakes to keep it sharp. Right?
Yes. Yeah,
Look for them, right? Ln, how you know if you can use ln? If there's a way for you to write the numerator as the differential of the denominator. Right, nice. If you can write it like that, then you're good to go. Right here, we have an example. Watch here. Watch here. Right here, we have an example. The denominator, if I differentiate denominator, I'll get 2x. So if I factor out the 5, all I have to do is multiply by 2x and divide by 2x, and I have my ln. Okay? You have to make the numerator a differential of the denominator. You have to write it in that form, right? Whatever you multiply the numerator by, you divide the denominator by. Don't forget that, right? Right, so the answer will be 5 on 2 ln 2x minus 1. Don't forget your ln rules, yes, sir? Sorry?
2 ln.
Oh, right. Yeah, that's it. Yeah, that's a mistake. That should be 5. That should be 5, right? That's what it meant to have. So take off that x there. Like that. That's a good sign. That's a good sign there. Right? Quick question. What can I do with that 5 on 2? Okay, that's power, right? So you remember, excuse. So anyway, we're talking about it. Right? 5 on 2, you can take it and put it as a power, right? Don't forget your ln rules, right? Don't forget your ln rules. Ariel Osama. Anyway, we will see if she stays to do it. Okay? So there's some rules for you to remember there. Right? Inverse trigs. Right? Inverse trig is like this. Once you identify this, you know that tan inverse, right? Once you get something over 1 plus x squared, you know that tan inverse, right? And if all else fails, like in this example, can I use ln here? No. Can I use tricks? No, because there's like 3x on top. And there's a square root here with x squared, right? So we had to use substitution. Let u equal to the part of the bracket. Alright, and you're good to go. Everybody okay with that? Next, integration by parts. So integration by parts, right? Integration by parts looks like this. If you end up with an integral that looks like this, that looks like this, right? You use integration by parts. So if you end up with a u and a tv, then we can split it up and use integration by parts. Question: if I give you something like this, x squared dot cos x, how do I choose my u and my tv? Huh? Yeah, all right. I just choose what to differentiate and what to integrate. Right? Yeah. Right. So basically, in the acronym, you're looking for the ability to differentiate and make it smaller. What that means that if you differentiate x squared, what you will get? If you integrate x squared, you will get what? Which is larger? X cubed, right? So once you can make the integrals, once you can make the function smaller, that's the one you differentiate. There are also some functions like cos and e of x that are recurrent functions. You don't differentiate those. All right. What happens if you get ln? Suppose you had ln in there. Suppose you had integral of x dot ln x. Which one will you differentiate? You differentiate ln, right? Because we parallelly integrate ln right now, right? So you differentiate this, that becomes a u, and this fella here becomes here. All right, and then find your u, find your v, find your du, and plug everybody into this nice formula. Right? If by chance you pick the wrong thing, what will happen is that the integral looks harder. Right? The purpose of integration by parts is to make it simpler. Right? To make that integral simple. And then sometimes we have to practice a technique called reduction formula. So for example, if I say, well, here's what you wish, integrate ln x to the power 10. We kind of hard, right? So what you do is you develop a formula, find the integral of ln x to the n, right? And then plug in and if 10 later on and move it down. Right? 10 minutes, you know what I mean, right? Okay. Right, question. When you're doing these, well, not question, another thing to note. When you're doing these, right? And you want to generate, for example, a formula that looks like underneath here. Right? A formula that looks like underneath there. Right. Here's what you need to do. The question will obviously tell you what is I to the n. You have to also write down what is I to the n minus 1. So that when you're doing the integral, you will say, oh, all right, that integral looking familiar, right? That is I to the n minus 1. Okay, so don't just work with I to the n, find I to the n minus 1. So when you do your integration by parts, it's easy for you to recognize what the substitute number is. That's okay? And last thing, trapezium law. Trapezium law, right? This is the formula that we use to find the integral. B and A are the limits, and n is what? N is the number of strips that you need, right? If it's 5 strips, by 5. Right? And each strip is what, Matthew? Each strip of an equal width. Alright? That's why the formula is designed like that. Right? Each strip has an equal width. Alright? So it doesn't seem like much, but that's everything you need to know for integration. Right? Not really, man. Wait, then I've been figured by tricks. Look at that smart man. Look at that. That's now, yeah. Right before you bring up out there. Right, I just want to go over some of the integrals here for you all to remember, right? Right, I went to the first step already. I just want to go through some of the integrals. Remember when you're integrating sine, right? The integral of sine is minus cos 1 over the differential bracket part here. Okay, I just want to go over that. Integral of tan is ln sec x. My important fella here, especially for differential equations, right? Okay. Right here, you have some other integrals. The integral of cosec is ln tan x on 2. Integral of sec squared tan x, cosec minus cot. These here, we did these yesterday. Right? Those are the integrals of 1 on the square root of a squared minus x squared. And tan inverse and so on. Right? The only one I want to kind of just write down. Write down this one here now, second to last. Just write down that one because sometimes we can forget that one. Just write down the second to last. Right down the second. Huh? Don't know, without looking. All right, you win. But I want to, that's important because it could also work with tricks, right? It could also work with tricks. Write this up. What is the meaning about that? Ready? 2024. Let me start one time.
I think it's not.
Start here, should have passed. Now we don't stick. Now we don't stick. Hurry up, 2024. Come stealing. You just track me and tell them. Hurry up, 2024. Start and pass. Remember, right? So apply the try it, you see, look. All right, well, I get really good part. All right, so let's go on to the second part. Right, so remember when you're working it out, and just making sure that you have the right thing at the beginning, right? You would recognize that it is not a quadratic. What they use? They factorize and get two linear, right? So 3x plus 2 right? So you're going to get e over 3x plus 4. Okay, well, I'm just it wrong, right? So it will look just like the answer. It will be e over x minus 1 and b over, right? If you do it properly, you're supposed to get a is equal to 3/5 and b is equal to 1/5. That's okay? Nice. Now you know what they're going to ask you. Oh, sorry, but you're right in there. What should I get up, right? What they're going to ask you now is how to integrate it. Right? But before you integrate it, just make sure it's the identical thing. Is it identical? Sometimes what it is doing is put a 4 here and 2 here and get a factor. Let's look up for those small things, right? How you would integrate this now? How you would integrate here? Log, right? Why not normal integration? Because if I bring it up, right? If I bring it up, you'll get 3/5 x minus 1 to the minus 1. We can't use normal integration there. Right? Because if you add 1 to the power, you'll get 0. Okay? So we have to use ln. So when I integrate here, I'll get 3/5 integral 1 over x minus 1. That will give me 3/5 ln x minus 1. Next one will be 1/5 integral 1 over 3x plus 2. So that'll be 1/5 ln 3x plus 2. Oh, sorry, 3. Yeah. Divided 3. That should be like 115. Here will be 3 and here will be times 2. Sorry about that. Right? When you reach there now, sometimes you can go one line again. You can go one line again, right? So you'll get ln x minus 1 multiplied by, right? X minus 1 to the 3/5 multiplied by 3x plus 2 to the 115. So I use ln of pluses multiplied and I use the power rule as well. Okay, so sometimes you can go as far as that. No, sometimes, not in this case. Everybody okay with that? All right, next one. Yeah. I know you just copying now. I try to work it out now, Shivish. What you do here, Shivish? Shivish, what do you think here? How you integrate this? Sure, it's not before now. And try to cut now. Huh? All right, hurry up. Nice. Same here, same here. Same here, parts. Number 2 party. Number 2 party. What you do here, Divish? Huh? Parts, like, without looking at the answers. How you break it up? Maybe, okay. But there's something you have to do. What you have to do here? You have to do it twice, right? So even if you have the answers, write it over now, try it over. Right? Huh? You can use sign up here, do a sign here. You can use TV or sign here, doesn't matter. Huh? Both are correct. Huh? Yeah, don't matter. When you have two nothing in between. Whenever if you have two recurrent functions, if you have two recurrent functions, then it don't matter which one it is. Same thing here. When we integrate, you keep choosing them. Oh, you have to do that twice, right? All you have to remember, whatever you stick with, whatever you differentiate first, stick with that. Yeah? if it should u as e to the 2x, stick with choosing e as the u, right? Keep it on. Yeah. What's that? Right, so I just plugging back in. I just doing over the integral there, right? I just plugging it back in. Right, what you will notice is that right, I factor all the fractions on same one time, right? You're confused. Yeah. Yeah. So I redo this, right? So I choose the u as e to the x and I choose the b as plus 3x. I differentiate, I integrate, and I plug it back in here. So I do integration by part twice. Right? And then all you have to do now is simplify and then do what? Bring all the integral. Bring all the integral e to the 2x sine 3x on the left side. And this one I don't talk about it. This one. Either right. You have to find the one top. I is equal to that. Right, bring everything on the left side and you will end up with right, I run out of space there, so I just go and add it, right? Watch this here. I'm going to move across minus 4 nines. I'm going to move across minus 4 9 on the left side. So I'll get 1 plus 4 9s, 1 and 4 9s, right? So I'll end up with 1 and 4 9s, which is 13 on 9 by the integral of e to the 2x dot sine 3x dot dx minus 1/3 e to the 2x cos 3x plus 2 nines e to the 2x dot sine 3x. Right? I move across all the integrals on the left side. So the reason I have 13 on 9 here, the reason I have 13 on 9 here is because 4 nines plus 2 1. That's it. Just carry across the 9 and 13 and you're done. Right? Carry across the 9 and 13. So multiply everything by 9 and 13 around that space. You just do that, right? And you have your answer. Multiply everything by 9 and 13 and you'll get your answer. Emily, trouble? Where you get lost? Looking like you have and now you get lost. Where you get lost? I just integrate twice, right? Right? Functions like cos and sine and e are called recurring functions. But once they integrate it, you'll keep getting e and sine and cos and trains. Yeah? Or do which one? So I move -4 and 9 by the end. Yeah, so I move it across and then I factor out. I move it across. So I'll end up with the integral of e to the 2x dot sine 3x dot dx added to 4 nines by the integral is same thing. And I factor out this. So I'll be left with 1 plus 4 nines by the integral. And this is 13 on 9. Right? 13 on 9. Right? Let's go again. Right, some people know working, so I'm gonna change the way I'm doing it, right? I'm gonna put the question, I'm gonna bring it on the board, and I will help you. Right? Starting with TH. Huh? Enough time to be a real yes to do. Integration alone today. That's it for module 2. Huh? Module 1, module 1, that's it, module 1. Tomorrow we start with differential equation because integration should be in here. Alright? Huh? What if it's supposed? Alright, so we still have more to do here. Reduction formula. Reduction formula, right? The trick in this one is you have to find right here, split it up. So instead of writing n, you write 1 by n minus 1. Okay? So the way you do this, because everybody do this in class, right? You write sine x by n minus 1. Right? That's the way it started. And here's an example of where you could see, well, here's what. I don't want to keep writing that. I could see that I to the n is the integral of sine to the nx. So what will be I to the n minus 1? Sine to the n minus 1. Try it now, please. Try it. I'll bring somebody on the board and we shall do it together. So here you pretend you're writing or we must come one time. Bishop chapter right 3. Let's start the right. Let's see. Who else? Shibish. Let Shibish only look up there. Shibish getting it for sure. Right, work it out. So it's technically a reduction formula. Well, tell it that. Right? But you have to figure out that full step. Good thing it is everybody do that, right? Okay, move it out fast. Right, let me see. Chivish, now write him. Come. So, since you want to get n minus 2, right? Since you want to get n minus 2, which one we going to differentiate? Which one we going to integrate? Differentiate n minus 1, because when you're minus 1, you'll end up with the n minus 2 that you need. So you differentiate it, integrate it. Try to leave it up, so work it out. No, write it down first. Yeah. Write down sine to the n minus 1x. That's not the same thing. X boy. Oh shit, hey, go. Take your time. Bye. I'm really fast. Really fast. Right? So remember to bring down the power. You leave it up. Bring down the power. N minus 1, right? Right? And differentiate sign. Bracket, second bracket, right? Plus x, y. Right? Now write back sign x in brackets and then minus 1 for its power. Minus 1 from n minus 1 will give you n minus 2, where the n magically going. Right? dB is equal to sin x. Nice. Integrate that. What's the integral sign? We got that one wrong, eh? Can I show you what it is? No, wait, this to me, I'm gonna time lapse. Just do the thing now. The sign is plus. Negative plus. Yeah, negative plus. P is equal to that. But keep working at. Don't wait one. Right now, use the formula. I to the n is equal to. What's the integration by past formula? You going good so far? We're not a little slow, but you get it right so far. What's the formula? Right, U by V. U by V. Yeah. What's U? Show me U and show me V. Right? Multiply them. Take your time, huh? Multiply by. I'm going to take a 3-hour video. Minus integral of v by d. Integral of integral. No, put the integral. V by d. Minus here. Normally, what I would do is put the constants outside one time. Go ahead. But I'm on. Like the question, you know what, 5 minutes? So you got 2 minutes already. Y'all done? Anybody get it? Right? Don't leave it out there. Dot dx. Dot dx. Right? Now you want to simplify a little bit. Don't worry with that part, don't worry with U and V so much, focus on here. Right? Focus on there. What you can do? I would pull the constants outside, right? So what you can do is you can take the n-1 and the minus and put it outside here. So this becomes plus n-1, and then what you can do here? I cancel the other. What you can do? What you can do? Cost by cost is what? No, cost, pull out the minus sign, that becomes plus. Pull out this, you get -1. Cost by cost is what?
Yeah.
All right, fix it there. No, when I say leave out this part, I don't mean right in back, you can't leave it out. Right in back, but don't put it -1. Yeah, work it out. That's right in back. Anybody get this yet? All guys? Almost. Smart shoot. You do the next one, eh? Should we take 4 minutes already? Right. I don't like the way you write, right? Oh, yeah, not symbol. It should be plus, from bracket, but I know this, right? So that becomes and minus. Right? And then take your time, take your time. Plus square. Close bracket. Fine, next. What you do there is simplify that. Put that in. Right? How you gonna simplify inside here? How you gonna simplify inside here? Right? So you have a slight problem inside the integral, right? You have a slight problem inside the integral. We have cos squared and this. What to do? Right. Change cos squared as and then multiply it out. Go ahead. You're almost done. Hopefully. 5 minutes. But I better watch my video, eh? Hey.
Whoa, it's
1 minus sine squared.
I know.
Sine video down. That one anyway. Right, so take the time and one. Put it square a little higher so you will see, right?
No one harmless. All right, back in the see.
Put I to the n equal to 1. Put I to the n equal to 1. I to the n equal to 1.
Oh.
Right? What you all will recognize, right? In exams in general, these same things will go on over. Right? Once you can do these principal things good, you'll stand a good chance, right? And they start to make the integration a little bit easier. As you can tell from 2024, if you look at the years before that, you'll see partial. All right. Right, multiply it out.
Sin x minus.
Sin x by 1 and sin x to the n minus 2.
Oh, yeah, it's sin x to the 4.
N minus one. N minus.
Yeah, you just put
Yeah.
Weird. Let's say
The mistake you make is some criteria. N minus 1.
Oh,
Right in from there. Cut off right. Don't take too long. Shabish come now, boys. It'll be 10 minutes. How did you start? 4x, this is something.
see ya. Wait, listen, it almost blind.
You're multiplying this here, what? You're multiplying.
Yeah,
1 by this will give you sin x to the n minus
Right,
2. Will line.
right.
And then you're multiplying
That by that.
2, you're adding the powers. So you'll get sin x to the n minus sin x to the n power. Nice. Right now, I had to separate it. All right, yeah, hold it for me. Get off my shot. Hold it for me. Get up. Right, so the last part is I to the n is minus sine to the nx, right? Dot cos x. I'm going to expand this out, so that will be plus n minus 1 by the integral of sine to the n minus 2 dot dx. This by this will give us minus n minus 1 by the integral of sine x to the n dot dx. Right, you'll recognize that we have I to the n here. We have sine to the n minus 1 cos x plus n minus 1. What this is here? What's the integral of sine to the n minus 2? I n minus 2. And what this is here? What this is? I to the. So I'll bring in all the I to the n together. So I'll get I to the n plus n minus 1 I to the n is equal to minus sine to the n minus 2 cos x plus n minus 1 I to the n minus 2. I could factor out I to the n here, and you'll get 1 plus n minus 1 is equal to this. Right? 1 minus 1 now cancel, so I'm moving that to n. So I'll get I to the n is equal to minus 1 on n of sine to the n minus 1 cos x plus n minus 1 on n I to the n minus 2. Is that the answer? Is that the answer? N minus 1. That's the answer. What I mean, basically.
Yeah,
That's the answer. All right, nice. Oh my lord, I think it's 13 minutes long. What about this one? No, no. Right, like online apprehension, they didn't even have to remove the screen. Right, so that is solution there. They have one more part, right? They have one more part. Right, any questions on that? Let's move on again. You can ask. What? Oh yeah, copy that and let's go. Next one. Still have more to this. Alright, let's go again. Next part. Aaron, relax yourself now, boy. Right here, if you do it now. Relax, take a little bit off and take Oh boy, yeah. What give you air? Relax now. Right? That's what we just did, right? Now you have to prove that. How are you doing that? N is what? N is 6. Hurry up. Still have more. So if you want happening in this, it's not hard, but how long it will take? Yeah. But then this part's short. Same here. This part 2 times. Yeah. Huh? Second line on the right hand side here. Where? Here? N minus 1. I multiply out here, I multiply this by this, and I multiply this by this. Right? Alright, so what you would recognize here is that the only way we could work that out, right? Is we're going to have to get n is 6. So you would recognize that you want to get I6. So that is minus 1 on 6 by sine 5 dot cos x, close brackets, plus 6 minus 1 is 5. So that's 5 on 6 I to the 4. Do we stop there? Nope, you gotta go and get I4. Then when you done I4, you gotta get I2, then you gotta get I0. And then put them back in and you get the answer. Right? Coming up. Come on. So you do the same thing, you find an I4. Then they will ask for I2. Then you find I2. Then you find I0 and then put them back in. Yeah, it's a little bit of working. Oh yeah, what's the name of that sign? So that trend now. Sham. Check on TikTok and see what it is. Huh? I0 is so I0 is simply 0. So where did I start? Where's I to the end? Watch. So when you put I0 is here, right? Oh, everything goes to 0.
Yeah.
Right? So here, look at this. We do this one. I0 is what? The integral of sine to the power of 0. And to the power of 0 is? So sine 0 is the integral of 1, which is x. Right? So sine 0 is just x. Sorry? Well, you had to do that. So you get these little pieces to get back the original answer. Right? And then you are I. Huh? Try working it out. Right, so let's check it out here now. You wanna answer the question? Why I had to keep finding I4 and I2 on here? Yeah. Yeah. Substitute. Say it again, instead of, yeah. And what you got? Wait, I get lost there. Plug the 2 into IN and you'll get the integral of. Right, what's the integral of sin squared x? Also, you assume that, so you know that the integral of sin squared x is what? Oh, I know understand what you mean. Yeah. The last part, the right hand side, I know understand what you mean. Yes. So that will save us a line. Oh, I now understand what you mean. So you don't have to work out the integral. Nice. Alright, so the integral of this will be I6. Right, I6 will be equal to, right, so again, so as we do the question, remember to look for those little things, right? Because remember, sometimes you're seeing this now because you see the answer already, right? But in exams, as you go along, take a little 2 minutes and just, before you start, just take a look at it, right? But now I just go on autopilot, so I just do it while it's over, right? So I6, so you work out, I'll work out I6 for you. Where the formula going again? Right, so that's minus 1 on 6. Minus 1 on 6 sine 5 x dot cos x. So you see when you're writing, right? Although you get a line, when you go to the line on the you're writing something else, better pay attention to go along, right? All of a sudden you magically end this up here, right? Right, but we still need to get I4, right? So I4 will be minus 1 on 4 sine cube x dot cos x plus 3 on 4 I2. And now we don't need to do anything because I2 right there, right? I2 is equal to the integral of sine squared x. And now we're gonna put I2 in here, and then we're gonna take I4 and put it in there, and you get your answer. Have you okay with that? Sure. Right, so now what does I4 become? I4 will be 1/4 sine qx dot cos x plus 3/4 by the integral of sine squared x. Oh, sorry, now scroll down. Thanks. Right, that's I4. And now I'm gonna help you find I6. I6 will be minus 1/6 sine 5 cos x. Sorry, yeah. 5/6 open brackets minus 1/4 by sine squared x cos x. Right, and then you multiply it out. You're okay with how to do this? Huh? Yeah, 10 to 3 now. 2023 now. So that was 2024. But what's the problem with the question that you're seeing?
Because this 100.
Besides that, time. How long it is? Yeah, you say you gotta put your head down and work or leave this for last. Right? Go and get the mass and come back, right? Module 2 and 3. Right? There you go again. Anybody find the answer? John Shane. Who do it take that take away? Yes, that. Any mic? But by that? Okay. They go again now, yeah. Alright, take a minute break and then we no no. 20% break themselves on the back on the floor. Right? Alright, so we're doing 2023 for those who want to go on time. Right out there. Fiction by crowds. No. Can you make series X squared? Yeah, right. That's it. Oh yeah, but you can differentiate, that. Right? As well. Yeah, but that's not left that you correct. Yeah, but that's tricky. Right? How this one went? Right, so what you're supposed to differentiate? Right, you're supposed to differentiate cosec squared x and integrate. So what's the differential of cosec squared x? Minus 2 cosec. Say that again. Minus 2 cosec. Is there next way? Okay, well, that was supposed to happen. That is what's supposed to happen, right? So here is sec squared x and here is right. What's the differential of sec squared? Two.
Where you got from? And we're supposed to be get less.
Yeah.
So I mean, yeah, it's going to be like this way. I was getting obsessed there. Yeah.
Which are away? That's something wrong. What's the integral of what's the differential of sec squared?
Sec squared x x. We're pulling to outside, right? Sec x is sec x x. And go up to sec x. And bring it all to about 2. With sec squared x.
Yeah. Oh, that's checking that. But here, you got a cosine, right? Let's check it out.
What? It's just.
All right, yes, but it's my, what's that? And minus cosx. And what you'll end up with?
Minus 1 over cos x sin x plus 2 brackets.
All right. Well, this is one option, but it's kind of looking kind of long and enough things in cancel. All right, so what you can do is try the other way. Try the other way and work it out, right? Huh? Yeah, you'll get the same answer, but find like this long and 3 lines down, short up. All right. Right, let's go again. Next one. Do this one fast. What are you doing here? Sorry. What are you doing here? Integration by chance and work it out. Check and see. Is it improper? Improper, right? You can't factorize this, so you'll have to leave it as that. Right, so that didn't work. So what's the next option? Huh? No, but if you use ax plus b, you'll end up with a being 4, a being 3, and b being 0. So you're going to end up right back here. So what you can use here? What else we can do? Think about it. If you use integration by parts here, right? What I'm saying is that what I'm saying, it can't factorize, right? So plus 5 minus 1, right? No. If you use, even if you use this, But if you use that ax plus b over the quadratic, you're going to end up right back here. You're going to get a as 3 and b as 0. Right? So what else we can do? Huh? With x squared. Yeah, once we rewrite it, bottom without. Alright, try it fast.
Writing the complex numbers
Like upstairs, I'm gonna take now. Try this one quick. Huh? So we have two options here, right? Make a substitution underneath. Whatever underneath, the whole thing. That's one option. Or can we break up x squared minus 4x plus 5?
Yes.
Complete the square. Right? Can we complete the square and then work it out?
Yes.
Try it and see now. Oh, your family. Try it quick. But what did you brought? By itself. Sorry? Or define k is c minus a squared. Define k is c minus a squared. Right. What you all end up with?
1 plus x minus 2 also.
1 minus.
Minus. Wow. Oh,
Yeah, so when it comes to the square, Sorry.
Yeah.
This one here. Right. So what I did here, right? I tried because this can factorize, it can't really break it up into anything, right? So what I did here was took the quadratic and write it in a complete square. Right? And when I complete the square, then I make a substitution. So I let u equal to x minus 2. So when I let u equal to x minus 2, I also make x subsequent formula. Yeah. Huh? From where? There's x on top. Right? But watch, it's going to happen now. Right? It's going to happen now. Right? So when you reach here now, when you make a substitution, you multiply it out. What did I do here with the 3 and the 0? I change the limit from x to u, right? So now I taking this 3 here and this 0 as my new limit. Then I break up this 3u1 u squared plus 1, and here I have 6 over u squared plus 1. It's plenty marks, right? So that's why it's so long, right? Right? When you reach here now, what is it? Well, what is the right hand side? No, right hand side. This one here. Now tan inverse, right? Now tan inverse. You recognize it? 1 over u squared plus 1, and left hand side here is next one will be ln, right? This one is ln because it's 3u, right? It's 3u. So when you reach there now, I'm not plugging in limits up yet, right? So that will be What would it be? 3 and 2? 3 and 2 ln u squared plus 1 plus 3 and 0 of what we said? Sorry, 6 tan into the 0. That's okay, it's plenty marks, right? And then you plug in your 3. Okay. And then plug in your 3 and plug in your 0. That's okay? I know it's real hard. But you have to realize that there was nothing you could have done with the substitution. Sorry, there's nothing that you could have done here. Right? There's nothing you could have done here. One of the other options here, right, is to let u equal to this. Right? No, but then you still have to come to this square and then make x circle. Right?
Do we need to track your bill or do
No, finish it out.
Sure. Okay. And then, do we want to check out this one?
No, get it work it out.
Okay.
No, the question said evaluate. Right? So you can't leave it like that. Right? So you gotta put it in and get the exact value, right? Plug in 3, plug in 0. If you write, watch, if you write like ln 10 and ln 0, you can leave that here. Right, but that's not where I reach. I still have to plug in 3 and 0. Okay? So you can't leave it there. You have one more step. And then basic stuff you can think, right? I mean, like you use the calculator. Right, and then it can be a solution. Okay. But again, in exams, what you would have tried to do was, in exams, you have tried to factorize. That would work. Right? In exams, you may have tried, or you may have thought about using formula, using partial fraction. That wouldn't work. So your only other option is to simplify the denominator. And all that will come to mind is here. It's a reduction. Copy this way. All right, let's go again. Next one. Try this next one here. Or you do this one here. Hey, what are you showing? What are you doing? Huh? For this, did you do this already? Or you have not? Try this, please. I want to follow. I want to follow. Forward, not mind. I don't want to be forward, divide by forward. I have to divide by fraction. Yeah, Wyatt. What do you think? What we can do? Huh? Put it into partial fractions, so it will be x by what? Right, x by x squared minus 9, and then you break up x squared minus 9. There's a partial fraction, right? Hurry up. Get that done. Huh? See if you have done an exam and I see you get high marks and I'm out of that. I want to get 20, you're going to get 4,000.
And you didn't set that exam, but it's not how to be exam. Where?
One percent, one. Oh yeah, try that quick. Question, 10 marks for this one, right? Well done. Again, sure. Try and work it out. So that don't look at anything, go look at the answer and then try to do it because the week that the next time you might get that right. Try and create that skill fire, it is take time. Ready? I go again. I think you're squeezing one more before we go. I'll pick up all one that nobody ever seen before, right? Well, let go again. Are we done? We continue. All will be done. All will be done. Alright. I think we can squeeze in one more now. So, alright, so just tell me what's the integral? Sorry, what's the partial fraction? 2 over
minus 1 x plus 3 minus 1
alright, and then
It's easy to solve the.
so altogether this it's you just expand the one compare. So you expand it out, you compare the nothing that is 0. Right? So you compare the coefficient of x greater than 0. X the 1 and the constant 1. Right? And then you integrate with respect to x, right? So you all got 2 nines ln x minus 3. Somebody said it's always done. That's not true, eh? Whoever said that. It's not always done. It's not always done. Right? Ln x. Right? And of course, you can look real smart and bring them all together, right? Alright, let's go again. Let's see if we can squeeze in one more now. Pardon me, sir. That's it after you do the partial fraction. Thanks, Alice. Right, question. What's this one here? Watch this here. Look at the partial fraction first, right? Sean, how you integrating this? Huh? This one here, yeah, the one with the hand. How you integrating 1 on x? That's a lot, right? How you integrating this too? How you integrating this? Huh? No way, just do partial fractions and you get it. Again, oh, that's wrong. Very good. So the order I was going to ask you is normal integration, that wouldn't work. That wouldn't work, right? Tricks will work here? No, so therefore, so you substitute what? U is equal to x squared plus 1. Nice, very good. Follow. Just integrate this fast now because we didn't do a substitution. Follow it easy, don't worry. What you will do here? No, that one's too easy. Let's do this one. Huh? Pass to the first one or because if you do parts, right? If you do parts, it will take a little while, but it will cancel off. Okay. You can also make a substitution as well. And see what happens. Can you make a substitution here?
Yeah, you can make
I know. Not here, sir. Not here, sir. Not here. Part 1, you go 1, then 2.
X to the power 3 is equal to
And then
x to the power 5 equals 20.
that's not other way. How we use square, right? Alright. Do your thing now. Try 1 and 2. No need, done. Just finish though. Gotta work it out now. Hurry up. Come on the board now and do that. Last one I'll be done on. Last one I'll be done. Promise.
One, right? What do you want?
1 and 2.
What's what now?
On the board,
What happened?
you come here, I don't know.
What kind of cup? Don't care what it is.
Alright, ready? So what we doing with part 2 here? Sorry, part 1 you all said integration by parts, that'll work out, right? Even if I do make a substitution, it'll cancel off nicely. But if I'm not mistaken, you're going to have to do integration by parts twice, right? Next one, Ashley, and we can go. Alright, well, tell me what to do here. Substitute what? As you? Any ideas here earlier? Let's.
It's up to you.
Alright, sorry, guys, I don't know that. Let u equal to 832x. Right, what you will recognize something real nice will happen. Right, you. Huh? Right, du dx is 2 e to the 2x. When you make dx the subject, you're going to get du over, and then this will cancel with this, and then you use inverse tricks and you will get sine inverse, right? Very good. Next one, pass. Did I talk about this one?
Yeah.
Talk about this one already?
Yes.
I remember that. Divish. Oh, yeah, to be cool class. I'm uncle, mother. You want it? Go to us. Right? This one here. What we said again? Divish. What we said here? How we integrating this 2x over x squared plus 1? Substitution. All right, nice. Good job. Hey, even with one part, I can call it English part. Looking like a real strict one.